Hello again. So this is my second video. I was rewatching and editing my first video and I realized that I had only used one color, black. And I have a lot of colors in my disposal, so I want to start using more. So I'm going to try to use a lot of colors in this video. Anyway, this video is on addition and subtraction of vectors. So I have two vectors here, A and B, and I really want to add them together. I'm tempted to just add their magnitudes because I have their magnitudes. I have 50 meters and I have 20 meters. But no, I can't do that. I can't just add the magnitudes together. Don't do that. My first point, I guess, is that vector A plus vector B does not equal the magnitude of vector A plus the magnitude of vector B. This is not accurate because vectors, of course, are quantities with both magnitude and direction. So we need to take direction into account when we're adding our vectors. So to get started in adding these vectors, I have taken my B vector and I've moved its tail to the head of the A vector. This makes sense because if we're thinking about it in terms of displacement, if I walked 50 meters in the east direction, and I should probably give this B vector a direction. So if I walk 50 meters east, I have to turn 30 degrees in order to walk my 20 meters this direction. So if we were talking about distance, you'd be correct to say my total distance traveled would be 70 meters, because that's true. I walked 50 meters this and I walked 20 meters this. But if we're talking about displacement, which is how far I am away from my starting point, we have to think of it in terms of adding vectors. And to get the distance from my starting point to my end point, I have to connect the tail of my first vector to the head of my second vector, like so. And we're going to call this the resultant vector because it's the result of adding A and B. So your resultant vector is equal to A plus B. Notice that not the magnitudes of A plus B, the vector A plus B. Another way to communicate this same idea is by using the parallelogram method, where I'm just going to make a parallelogram with the vectors I have. So I'm going to have this B opposite to the B I have over here, and this A opposite to the A I have over here. And then this helps show me that A plus B is the same as B plus A in this case. And the resultant here will be the same as the other method, where we put it tip to tail. So I'm just going to erase this part of the parallelogram for now, because I want to focus in on the angles for a second. So we know that this vector is south 60 degrees east, which means we start in the south direction and we went 60 degrees in the east direction. So that means this angle from here to here is 60 degrees. And we know that this angle is just east, or in other words, it's horizontal to our x-axis, which must mean that this angle, since this angle is south, this would be 90. It's a 90-degree angle here. So then we can find out our angle in this entire thing by adding 90, it's a terrible 9, by adding 90 and 60, because those are the two angles that make up this, and we get 150. So 150 is our angle right here, and we need this. We need this 150 so we can use cosine law in order to find the magnitude of our resultant. Our resultant is opposite to this 150 degrees, so we can use these two angles to find A plus B. So I got about 68.06, and our units are meters, so it's 68.06 meters. Also note that I'm using magnitude bars for my resultant because this isn't the final vector. Need to find direction, which I'm going to do right now. So I want to find this angle right here because that's where my resultant vector begins. It's where its tail is. And now that I have the magnitude of the resultant, I can use sine law. So I know that sine 150 is opposite to 68.06. And I'm trying to find the theta, so sine theta over 20. And I'm going to cross multiply. And the angle I'm getting is about 8.45 degrees, which is a pretty small angle. But if you remember from my last video, we always like to get our angles starting from the south or the north. And right now this angle would start from the east. So I need to get the complement to this. So if I put this angle as alpha, I can make alpha equal 90 minus 8.45. That gives me about 81.55 degrees. So I can sum this whole thing up and say A plus B is equal to 68.06 meters south, 81.55 degrees east. Cool. All right, now that we can add vectors, we can also subtract vectors, which is also tons of fun. So say we had the same vectors we had at the beginning, but the question now is asking us A minus B. How would we do that? Again, we can't just subtract the magnitudes, but if you remember from the first video when we were talking about opposite vectors, the magnitude of B is equal to the magnitude of negative B. So visually, that could be represented like this. Subtraction is the same thing as adding a negative, so we can rewrite this as A plus minus B, and then we can just simply do our tip to tail method again, where this can still be A, and then instead of using positive B, we put in negative B. And now this is our new resultant. The parallelogram method also works for subtraction of vectors. So for the parallelogram method, we're just gonna look at it visually. So if this would be the resultant of A plus B, and we know from here that negative B is simply a flipped version of B, then we can say that this would be A minus B, because we're going the positive direction of A and we're subtracting B, if that makes sense. This is the last thing, I promise, but we can also represent addition and subtraction of vectors with points. So for example, if we had something like AB plus BD, we can just start at our A, follow it to B, and because B is the start of the second vector, we can just follow B to D. So our resultant is just going to be AD. Subtraction of vectors with points isn't that much harder. For example, if we had AC minus DC, we know that negative vectors are simply the opposite of their positive version. So we can change this to be positive CD. And then we can just do the process that we did up here again. So AC would be from here to here, and then plus CD, we start at the same point. So CD would be here. So coincidentally, we get the same result as we did for the first question. Final one, DA minus DB. What does that equal? I'm just gonna go ahead and make this into its positive. So first of all, I'm just gonna go from DA, D to A, and then plus BD. We're not at point B right now, but if I see here, BD, if we're assuming that this is a rectangle where these lines are parallel, which I didn't do a very good job conveying that, but if we assume that, then we can say that BD is the same as AC because they're parallel and they're equal in magnitude. So we could rewrite this as DA plus AC, and then that's going to equal DC. Okay, I'm going to go and edit this and see if any of it made sense, and then I will be back for multiplying by a scalar. Thank you.